All right, hello, Accelerated. So, we're going to start our unit on what is called systems of equations. Now, this is something that you really do need to be paying careful attention to because this will come back in Algebra 1 and they will not be reviewing it. They expect you to know this and understand this, and they'll be going to the next level of it. So I want to make sure that you truly understand this. But when we solve a system, there are going to be multiple methods to solve the system. And we're going to look at all the different methods. And bear with me on them because there's an easy method, there's a medium easy method, and there's a difficult method. But we'll get into that and we'll talk about all that and how it works. But let's start with a question for you. If I give you the following two equations, the first equation is 2x plus y equals 5. And the second equation is y equals negative 1/2 x plus 2. Now, I want you to take a couple of seconds here, and I want you to think about what do these two equations have in common? And I'm going to warn you, I want the obvious, not the merely obvious. No, don't want the obvious. I want the merely obvious is what I meant to say. But think about what these two equations have in common. And no, it's not because they both have an x and a y. No, it's not because they both have a plus sign or 2's in it. It's something else. So pause your video and take a think about this for a second. So what did you think? Come on, tell me. What did you think? You have any ideas? No? Well, let me show you something. So I want to put in here a graph. And actually, I wanted to do it this way. I want to put a graph in here. And let's write down these two equations again. The first equation was 2x plus y equals 5. And the second equation was y equals negative 1/2 x plus 2. And, sometimes what an equation has in common is we have to look at it visually. So I want to graph these two equations. So let's start with 2x plus y equals 5. And I know automatically from this that if I let x equal 0, that y is going to be 5. And so I have the point 0, 5. I also know that the slope of this line is negative a over b. So it's negative 2 over 1, which means I go down 2 and over 1. And if I do that, and I can even do that again, go down 2 and over 1 more, go down 2 and over 1 more. I could keep doing it until I get to the bottom of the graph, but I think we have enough there. And I'm going to draw my line connecting all those dots. So there's the first line. The second line, nicely that's in slope-intercept form, so I already know it's at 2, 0, 2. And it says the slope for this one is negative 1/2, which means it's going down 1 and over 2. And down 1 and over 2. And down 1 over 2. So if I connect those dots together, connecting those dots together, it's pretty bad there, but one of the things that I've noticed right away, and that you might actually notice, is that these 2 points, two lines cross. And where they cross, they have a single point in common. That is a point that is a solution to both the red graph and the blue graph. and which means it's a solution to both those graphs. It is what we call the solution to the system of equations. And in this case, that means the answer is the point 2, 1, and that is the answer to the system of equations. So what we're looking at here is to find a solution or to find the answer to a system, we're looking for the point that they have in common, or the ordered pair they have in common. And in this case, it's the point where the two lines intersect. Okay, I'm going to give you two equations, and let me give you y equals 1/3 x plus 3, and y equals 1/2 x plus 4. And I would like you to take those two equations, and I would like you to graph those two equations, and I would like you to tell me where they intersect. So go ahead and pause the video and graph those two equations and tell me where they intersect. Okay, if you did that correct, you would have you would have told me on the first equation, you would have said it crosses the y-axis at 0, 3, and it goes up 1 and over 3, and up 1 and over 3 is over there, and I'm going to do something a little crazy. Not only does it go up and over, but it also goes down and back, down and back. And I always try to draw my line as long as I can. So there is my first equation. Did you get that graph correct? And this is why it's so important to know how to graph your lines, because if you can't graph a line, you're going to mix these up all the time. If we did the second equation, we know that the y-intercept is at 0, 4, and it's 1/2, which means it was up 1 and over 2, up 1 and over 2, and again I go down 1 and back 2, and down 1 and back 2, and down 1 and back 2, and at that point you should obviously be seeing at this point that they do actually cross. There is a point of intersection. It's right there. And that point of intersection is in fact the point -6, 1. And that is the solution to the system of equations. All right, let's try one more here. Try this one. 2x minus y equals -4, and x plus 3y equals 5. Would you graph and find the system of equations and tell me where they intersect, the point of intersection? And yeah, so pause the video and see if you can figure it out. Okay. If you did this one correctly, let's take a look at this. You would have noticed on this one that I could have found on this here, I could have used my two intercepts. Because if I let x equal 0, I would have found that y was equal to 4, so it's the point 0, 4. If I let y equal 0, then I know I have my x is going to be equal to -2 for -2, 0. And now I can graph my line. So I'm going to draw my graph here. There we go. On the second one, if I let x equal 0, y is 5/3. That's not good. I really don't like when that happens. Let's see if I let y equal 0, what happens. If y equals 0, x is equal to 5. Well, that's good. I can use that. So I can use, oh, nope, sorry, hold on. Sorry, I blew that. If y is equal to 0, x is equal to 5. There we go. I graphed that backwards because it's 5, 0. And in this case, I have to look at the slope. The slope is going to be negative a, which is going to be negative 1 over 3. But to go down 1 and over 3 is going to be tough on this graph. So I might flip it around a little bit and make this 1 over negative 3, which means I could start at the x-intercept, go up 1 and back 3, go up 1 and back 3. And when I draw my graph, I find that there actually is a meeting point. It crosses right there, which is the point negative 1, 2. How many people got negative 1, 2? Awesome. So, one of the things we've discovered so far is that when I'm graphing two lines, so I graph one line here and one line here, that they can intersect. But there are two other possibilities. They may not intersect, and you probably are wondering, how is that possible? Well, take a look at this. If I have a line that goes like this and a line that goes like this, what kind of lines are those? Correct. Those are parallel lines. And if they're parallel, will they ever intersect? No. So in this case, we say there is no solution. Because how can there be if the two lines are parallel? There will never be a solution. They actually have nothing in common. Well, they actually do have one thing in common. Their slopes are exactly the same, and you'll discover that later. But in this case, there is no solution. They don't have any points in common. The other situation that could happen is this situation. You graph the first line, and when you go to graph the second line, it's exactly the same line. That means both equations were exactly the same. In this case, so this is where they are the same line. And if that's the case, how many solutions do they have? That's right. They don't have 1, they don't have 2, they don't have 3, but they have infinitely many solutions, because both lines are exactly the same. So every single point, this point and 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 this, they're exactly the same. They're always the same line. So there's infinitely many solutions. So there's 3 scenarios that could happen. There could be one point, one solution, infinitely many solutions, or no solutions. So that is how we solve a system of equations, is we solve it by graphing. And we graph the two lines and we see what happens. So I leave you with that today. You need to go and check out your Edulastic assignment. There are actually 2 assignments for this one. There's a part 1 and a part 2. So please make sure you do both parts. And on Thursday, we will talk about, we'll go over this during a Zoom session. If you have questions, then please make sure you come online and talk to us about it. And remember, during the Zoom session, sometime during the Zoom session, I will be giving you a code word. And that code word is what you'll use to check in for the class, to let me know that you are actually at the Zoom session. But you have to be in the session to get the code word. You can't get it otherwise. With that, have a good rest of your day. Good night, and I will see you during Zoom.